Today we are going to conduct the last class, okay, of inverse trigonometric function. That day we are discussing this question, okay. So I'll continue with the last class. We have to find out this way. So basically I have to go from sine inverse to sec, then sec to cot, then cot to cos, then cos to tan, and finally tan to sine. That's what we have to find. And it was given that A was lying between 0 to 1. So basically the question is asking us to find sine of tan inverse of cos of cot inverse of sec of sine inverse of A. Okay. So let me consider sine inverse of A equal to theta in a right angle triangle. Theta. So I'll get sine theta equal to A. So sine of theta equal to A is perpendicular by hypotenuse is A. So this one will come square root of 1 minus A square. So I need sec. So from here we can find out the sec theta. Sec theta will be equal to hypotenuse by base 1 by root over 1 minus A square. Therefore, sine of tan inverse of cos of cot inverse of sec of sine inverse of A we have got as sec inverse of 1 by root over 1 minus A square. 1, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So sine of tan inverse of cos of cot inverse of sec inverse of theta is 1 by root over 1 minus A square. 1, 2, 1, 2, 3, 1, 2, and 3. Now our work is to go for the changing between cot and cos. Again we'll take cot inverse of suppose 5 equal to 1 by root over 1 minus A square. So again we'll consider one right angle triangle. Phi so that cot phi equal to 1 by root over 1 minus A square. The cot is the ratio between base and perpendicular. So base and perpendicular. And this one will come sum and the square of this. So 1 plus 1 root over 1 minus A square whole square, that is 2 minus A square. So what I need a cos, so cos phi is by hypotenuse, so 1 by root over 2 minus A square. Therefore, from here I write sine of tan inverse of cos inverse of 1 by root over 2 minus A square. So basically we will be living with sine of tan inverse of 1 by root over 2 minus A square. One more step to go from tan to now. We have to go for sine. So again let tan inverse of 1 by square root of 2 minus A square is equal to something else. I will take anything you can take actually m. So tan of m 1 by root over 2 minus A square. Again we'll consider one right angle triangle. Tan is the ratio between perpendicular and base. 1 by root over 2 minus A square. Hypotenuse hypotenuse will be sum in the squares of this, the square root of 3 minus a square. So finally we get here sine inverse of. So what do I need? Sine m perpendicular by hypotenuse 1 by root over 3 minus a square. 1 by root over 3 minus a square. This will be the answer actually. 1 by root over 3 minus a square. That's it. Okay. Okay then. We'll go for the next question. Solve cos inverse of x plus cos inverse of x by 2 plus 1 by 2 root over 3 minus 3x squared equal to, it is going upward. To solve it. Okay. So what we'll do, before going for anything, we'll observe this. Can it be simplified? Can any identity be used here? That we have to think. Whenever this kind of question comes, we have to work on that. Can it be simplified using some standard properties or standard identities? Okay, so this, if we'll observe carefully, it is nothing but cos inverse of x into 1 by 2 plus, here 1 root 3 can be taken common, so it is basically root 3 by 2. Root 3 by 2, that can be written as 1 minus 1 by 4. Will I get root 3 by 2? Yes. And whatever left out, that is 1 minus x squared. I am just writing this one. This cos inverse x will come as it is, equal to pi by 3. Okay. Now then, this one is looking like the property, the identity what we have. Cos inverse of xy plus root over 1 minus x square into root over 1 minus y square. This one will consider 1 by 2 to be y. This one is square of y, square of half. Okay. Now here one thing, before we apply this, we have to check whether x is greater or 1 by 2 is greater. Hence whether it is this one or this one, that we have to check. After that only we can apply this formula. Okay, this has two results. If x is greater than or equal to 1 by 2, then this one will come cos inverse of half minus cos inverse of x. And if half is greater than x, then it will come cos inverse of x minus cos inverse of half. Many of the students, they will do this. Cos inverse of x plus cos inverse of x minus cos inverse of half equal to pi by 3. So 2 cos inverse of x equal to, this one will go there, it is pi by 3 only, 2 pi by 3. So 2 to cancel, cos inverse of x equal to pi by 3. So x cos inverse of x equal to cos of pi by 3. That is half. Half is the answer. But that is a wrong thing to do. That will be wrong. Before writing this, we have to check whether x is greater or half is greater. Okay. So we'll now do that. Now how to check whether x is greater or half is greater? From here. this function to exist, I must have x square to be greater than or equal to 1. Less than equal to 1, sorry. X square has to be less than or equal to 1. And obviously x square will be always greater than 0. So x square is lying between 0 to 1. Means x also will lie between 0 to 1. Okay, so we are looking for half, so I can say that x is greater than half but less than 1. So ultimately x is greater than half. X is greater than half. Okay, x is greater than half. Therefore, we must write, let's say the logic is this: cos inverse x is a decreasing function. It decreases from pi to 0. This one is pi. This one is cos inverse of x. Again, sorry, this one is pi. This one is 0. This one is 1. This one is minus 1. Domain is minus 1 to 1 and range is 0 to pi. Okay, so it is a decreasing function. It is decreased from pi to 0. Okay, so in decreasing function, when x1 is greater than x2, fx1 will be reversed. Fx1 will be lesser than equal to plus. So we are going to use cos inverse of x plus. So x is greater, so x will be negative, minus cos inverse of x. And here we get cos inverse of half equal to pi by 3. Cos inverse x cancel, and we are getting cos inverse half equal to pi by 3, which is an identity. Therefore, the required values of x will be from half to 1. Cos inverse of x plus cos inverse of 2x plus cos inverse of 3x is equal to pi. And if x satisfies what it satisfies, ax cube plus bx square plus cx minus 1 equal to 0. Find the value of a plus b plus c. Again, we have to find this a plus b plus c. It is given that this equation is true and x is satisfying this equation. Ultimately, they are saying that x is a root of this equation also and x is a root of that equation also. So we have to find out, under that condition, we have to find out the value of a plus b plus c. So let us solve it. No way we can solve this. So there is a possibility that we may solve this. So I am writing this cos inverse of x plus cos inverse of 2x is equal to pi minus cos inverse of 3x, transposing the third term there. We will apply the formula for cos inverse of x plus cos inverse of 2x, the first formula actually, because nothing is given, so we will go for principal value branch of x. So cos inverse of xy, that is 2x square minus x root over 1 minus x square into root over 1 minus 4x square. And right hand side, pi minus cos inverse of x we will write as cos inverse of minus 4x. both sides if we'll take cos and cos inverse will engage themselves, so we'll be living with this 2x square minus root over 1 minus x square into 1 minus 4x square equal to minus 3x. So transposing this terms is equal to square root of 1 minus x square 1 minus 4x square, so we'll square both sides to get 4x to the power 4 12x cubed plus 9x square, and here I'm going to get 1 minus 5x square plus 4x to the power 4. This term and this term cancels each other, so we'll be living with 12x cubed plus 14x square minus 1 equal to 0. Now we'll go for the second part. This one is given that this equation, the x is satisfying this equation. So now if I compare this result with this, so comparing, get a equal to 12, b equal to 14, and c, there is no coefficient of x, so c equal to 0. Therefore, they have asked for a plus b plus c. So a plus b plus c will be 26. That's the answer. Evaluate. Summation of n from 1 to infinity. Tan inverse of n by n plus 2 minus tan inverse of n minus 1 by n plus 1. Here this is what we have to evaluate. Okay. Let us put the values of n, and let us check what this sequences exactly look like. So I'll put the n equal to 1, tan inverse of 1 by 3 minus tan inverse of 0. That will be the first term. This plus I am writing because of this summation. Plus n equal to 2 by tan inverse of 2 by 4 minus tan inverse of 1 by 3 plus put n equal to 3, tan inverse of 3 by 5 minus tan inverse of 2 by 4 and so on. The nth term will be definitely this, tan inverse of n by n plus 2 minus tan inverse of n minus 1 by n plus 2 plus so on up to infinity. Okay. Now if we will observe carefully, we will find that these terms gets cancelled. Tan inverse of 2 by 4, tan inverse of 2 by 4, and that this keep on going cancelled. So ultimately we will be living with only this term. This term will be cancelled with the term before that. So we will be living with tan inverse of n by n plus 2 minus tan inverse of 0, that is 0. Okay, so this one we can consider as Sn. Now we need S infinity. S infinity can be found out using the limit n is tending to infinity. So how do I get this limit? divide by n, we'll get 1, 1 plus 2 by n. 2 by n when n tends to infinity will be 0. So this one is nothing but tan inverse of 1. So I hope you have understood. Evaluate tan inverse of 4 by 7 plus tan inverse of 4 by 19 plus tan inverse of 4 by 39 plus tan inverse of 4 by 67 plus so on up till infinity. This is what the question is. Okay, we have to observe the question carefully and we have to understand the pattern, what pattern it is following. Since it is a sequence, so it must have a pattern. So we have to observe the pattern in this kind of question. So and we'll try to find out nth term if possible. Nth term will be tan inverse and definitely numerator will be 4. The question is what pattern the denominator is following, right? This one 4 plus 3. That one is 16 plus 3. And this one is plus 3, 36 plus 3. And this one is 64 plus 3, right? Okay. So can we write 4n square plus 3? Right? 1, 7, 2, yes, 19, 3, yes, 4, 16, 4s are 64 plus 3, 67. So this is the nth term. Now, here comes the most important step. Of course, this is also another important step to get the nth term correct. Okay. Now, this is a kind of question. We are going to get a lot of questions like this. Here we are going to use this formula, tan inverse of x. Already I have discussed this. Tan inverse of y is equal to tan inverse of x minus y upon 1 plus xy. Now this formula is this, but this identity in this kind of question we are going to use this way, the reverse way. Means we are going to make tan inverse of x minus tan inverse of y out of this. We will try to split this into two parts. Okay, that is the challenge, and that is the trick of solving this kind of question. Okay, so how to do? Tan inverse. First of all, we'll try to get rid of this constant, which is there in the numerator. Means we'll divide by 4. 1 by n square plus 3 by 4. Now what we are looking at, we have this and we have to get back to that. So basically this one is this. Okay, so I have to express this term like this. Denominator will be 1 plus x into y. So denominator, since 1 plus term is there, so let me add 1 and subtract 1. So I get n square plus 3 by 4 minus 1 means minus 1 by 4. Numerator will not change. Now only thing I have to do is how to express this one as product of two terms. And that two terms, when we add, that must give me the numerator. Okay, let us see. Tan inverse of 1 plus n minus n plus half into n minus half. Now all I need to check whether this two term sum is giving me 1, that is numerator. Sorry, difference. N plus half minus n minus half. So work is half done. Okay, half of the problem is solved. We are getting n and cancel, half plus half is 1. So this one is exactly looking like this now. Okay, so from this step I can write tan inverse of n plus half minus tan inverse of n minus half. Okay, this is my Tn. I have to get Sn. Okay, let me find out Sn then. Therefore Sn. Okay, how do I get Sn? You have to add all the terms, right? So let me find out the terms first. T1 will be equal to, we put n equal to 1 to get tan inverse of 3 by 2 minus tan inverse of 1 by 2. T2 tan inverse of, we are putting n equal to 2 plus half, that is 5 by 2 minus tan inverse of 2 minus half, that is tan inverse of 3 by 2. T3 tan inverse of 3 plus half, that is 7 by 2 minus tan inverse of 3 minus half, that is 5 by 2. And so on. Nth term will be this one only, Tn. Okay, now if we observe, we will find that this terms are getting cancelled. Okay, if we go on going like this, the only terms we will be leaving is tan inverse of n plus half minus tan inverse of half. Okay, so if I am going to n, that will give me Sn. And Sn will be equal to sum of all these terms, T1, T2, T3, T4 till Tn. So we'll be getting tan inverse of n plus half minus tan inverse of half. Almost getting the answer. This is Sn. And we are looking for S infinity. So when n will tend to infinity, this one will be infinity, tan inverse of infinity, we know it to be equal to pi by 2. So S infinity will be equal to pi by 2 minus tan inverse of half. It can be written as cot inverse of half. Okay, it can be written as tan inverse of 2. This is the answer. Any one of these three can be the answer. Okay, so this is how we do this kind of question. Okay, so before we go ahead, let me take another question. The question is, for x belonging to 0 to pi by 4, let Sn equal to summation of n from 1 to 2n sine of sine inverse of x to the power 3r minus 2. Tn equal to summation of n from 1 to 2n cos inverse of x to the power 3r minus 1 and Cn equal to summation of n from cos for C tan for T and Tn equal to n from 1 to 2n tan inverse of x to the power 3r, where n is a natural number, any natural number, greater than or equal to 3. Then arrange Sn, Cn and Tn in descending order. Okay, let us discuss this question. It is given that x is lying between 0 to pi by 4. Sn is the summation of n from 1 to 2n sine of sine inverse of x to the power 3 or minus 2. Cn equal to n from 1 to 2n cos of cos inverse of 3 or minus 1. And Tn equal to n from 1 to 2n tan of tan inverse of x to the power 3 or where n is a natural number greater than or equal to 3. We have to arrange Sn, Tn and Cn in descending order. Okay. Now we know sine of sine inverse of any real value, that will always give me that real value. Okay. Similarly, cos of cos inverse of theta equal to theta for all real theta. Tan of tan inverse of theta is equal to theta for all real values. So we get sine inverse of sine inverse, sine of sine inverse of x to the power 3 or minus 2. So this one will give me x to the power 3 or minus 2. Cos of cos inverse of x to the power 3 or minus 1 will give me x to the power 3 or minus 1 only. And tan of tan inverse of x to the power 3 r will give me x to the power 3 r. So basically these summations are nothing but this Sn equal to summation of n from 1 to 2n. So it should have been r from 1 to 2n. R from 1 to 2n. Sorry. This is r1. R from 1 to 2n, x to the power 3 or minus 2. So let me write down a few terms of it. When x equal to 1, we'll get x plus r equal to 2, 6 minus 2, x to the power 4, plus x when r equal to 3, 9 minus 2, x to the power 7, plus so on. It will go till 2n, that is x to the power r equal to 2 and that is 6n minus 2. Not necessarily writing this. What we can do, x can be taken common, 1 plus x cubed plus x to the power 6 plus so on up to n terms. Okay, is it up to n terms? Up to 2n terms. Okay, it is a ZP. Now x is lying between 0 to pi by 4. It is given that x is lying between 0 to pi by 4. Please pay attention here. Pi by 4, the value is pi by 2 is 1.58. So pi by 4 will be half of that 1.58 means 0.79 or something 78. So definitely it is less than 1. Means x is lying between 0 to 1. Basically it is less than 1. So we are applying the formula for ZP, so we need where x is lying, right? So x is less than 1. So what we'll do? R is x cubed to the power n, that is 2n. 1 minus, sorry, we should have written 1 minus because x is less than 1. So 1 minus of by 1 minus of 1 minus x as we know, x is less than 1. Less than or equal to 1. No, less than, strictly less than 1, sorry. Strictly less than 1. So basically I'll get here x into 1 minus x cube, 1 minus x to the power 6n. So let me leave this one like this. Okay, now let us calculate Cn. I hope calculations are correct. A r to the power 1 minus r to the power n by or 1 minus r. A is 1. Okay, let us go for Cn now. Cn will come summation of r from 1 to 12 and x to the power 3r minus 1. So again we'll put the values of r, 1 to 3 and so on. So if we put 1, we'll get x 3 minus 1 x square plus 4 minus 1 3 plus 9 minus 1, that is 8, plus so on up to 2n terms. X square can be taken common, so we'll be getting 1 plus x plus x to the power 6. X square we are taking common, right? So 1 plus x plus x to the power 6 plus up to 2n terms. Okay, 3 to the 6 minus 1, this one is 5. So basically we are getting the same sequence. So we'll get x square into the same thing, 1 minus x to the power 6n by 1 minus x cube. Similarly, if we calculate Tn, we are going to get this. We are going to get exactly proceeding the same way. If we go for Tn, Tn will come x cube whole into 1 minus x to the power 6n by 1 minus x cube. And we have already calculated Sn as x whole into 1 minus x to the power 6n by 1 minus x cube. Now we are looking for the descending order. Now look here. X is less than 1, so x square will be less than 1, x cube also will be less than 1, and what will be the descending order? X cube will be lesser than x square will be lesser than x, and since in all these three sequences this is common, so the descending order of Cn, Tn and Sn will depend upon ultimately x square, x and x cube, therefore required descending order. When in descending order, so the highest one is Sn is greater than Cn is greater than T. And this is required descending order. The next question is, if fx equal to sin inverse of x plus tan inverse of x by cos inverse of x plus cot inverse of x, find the range of f. To get the range of f, the function is given this. Now, before proceeding to the range, let me see if it can be simplified. sine inverse, cos inverse, tan inverse, cot inverse. So we have some sort of arrangement can be done. So what we'll do, sine inverse will write pi by 2 minus cos inverse of x, and tan inverse will write pi by 2 minus cot inverse of x. And obviously from here we can write pi by cos inverse of x plus cot inverse of x minus 1. So fx is this. Now since we are looking for rings, so wherever this function will be maximum, denominator function I'm talking about, cos inverse x plus cot inverse x, okay, and fx will be minimum there, and whenever this one is minimum, fx will be maximum. Please understand this point, okay? So all I need to take, what is the maximum value of this cos inverse x plus cot inverse of x, okay? For that we need to check what are the values of x can have. Cot inverse x, what is the range? What is the domain? Cot inverse of x, the domain is entire real number, okay? And cos inverse x, the domain is from -1 to 1. So since there is sum of these two functions, so their common domain will be -1 to 1 only. So x is lying between -1 to 1. I am talking about this function only, the denominator function. Now we have to find out the range. -1 to 1. What will be the range of this function? Or what will be the maximum value of this function? So let me draw the graph of cos inverse of x. Cos inverse of x is lying between 0 to pi. It is decreasing. And cot inverse of x. Cot inverse of x is also this one is cot inverse of x and this one is cos inverse of x. Okay. And common domain is here. -1 to 1. And we don't require the other part of the graph because we are going to working on the domain. So maximum value is obtained at, this one is decreasing function, this one also decreasing function. So maximum value will be obtained at -1. Okay, the maximum value of this function will be obtained at -1, and the minimum value will be obtained at 1, x equal to 1. Okay, so fx pi by cos inverse of x plus cot inverse of x, this one when it is maximum f will become minimum. F minimum is this. Okay, please understand. Okay, now you know that the maximum value from the graph, the maximum value is obtained at -1. Okay, for both the function. So cos inverse of -1, that is pi, plus cot inverse of -1. Cot inverse of -1, this one will be obtained at 3 pi by 4. How come pi minus cot inverse of 1? Pi minus pi by 4, that is 3 pi by 4. So this one is 3 pi by 4 minus of 1. So we'll be getting 3 pi by 4, pi plus 3 pi by 4, 5 pi by 4, pi cancel. So 4 by 5 minus 1. So am I getting minus 2 by 3, minus 5 minus 1 by 3, minus 1 by 5. F minimum, let me check. 5 pi by 4, 4 by 5, 5 pi cancel, minus 1, so minus 1 by 5. And f will be maximum when this function will be minimum. This denominator function will become minimum. Cos inverse of x plus cot inverse of x is minimum. Okay, now let us check where it is minimum. Clearly it is minimum when x equal to 1. X equal to 1. So pi by cos inverse of 1 is 0. Plus cot inverse of 1 is definitely pi by 4. Minus 1. So, right? Okay, so we get minus 1 minus 3. Therefore, range of f go from minus 1 by 5 and the maximum will be 3. Oh, this one is 7 pi by 4, right? Calculation error here, minus 3 by 7. That's the answer. Okay.